Hi everyone, my name is Joshua from TAG. In this video, I will be teaching on proportion and percentages in R, and we will be using the same data we used in the previous video on the usage of count function in R programming. So the data we used was the Cheek WTS dataset, and we stored this data in a variable called DAT. So we do the same again, and then the first thing we want to understand is the concept of proportion. So let us say we are asked to find out the proportion of the chick that was fed with the first level of milk, which is the casein. So what we are going to do is to say we take the sum of that $feed that belongs specifically to casein, and so when we take this sum, we're expecting to have 12. So to understand the proportion, so we divide it by the number of rows that we have for the entire data, that. So when you run this, you could see that the proportion is like roughly 16%. So if you are doing this all again for all the levels, again I print like what I did in the last one. I print the levels, unique levels of the feeds, and then we have it in this way. So let us say we are doing what we have in this place now, Ctrl C, and then I'm pasting it. We are doing it as well for husband. So if I run this, we could see again the proportion that belongs to husband, the proportion of chick that was fed with husband. So this again could be time wasting, so let's use the typely function from the base package, and so supply this with the first argument, the vector of the weights, and the index variable that we'll be using would be again the categorical variable, which is the feed, and here we have to provide the function. In the previous video here we supplied the mean because we want to understand the mean of the chick weight on the basis of the feed, but here we want to have an understanding on the proportion of the chick that were fed with each of the unique levels of the feed. So here let us create like a kind of disposable function, and so let us use a dummy argument called x, and here what we are going to do is to say take the length, because we want to take the length of the dummy variable s, which stands for the vector of weights, and so that's why we're using length and not number of rows. So I'm saying length divided by the number of rows for DAT, and so if I run this entire thing, so we have the proportion all across the feeds. So in a case where we just want to understand again the percentage, it's just a matter of I'm copying everything we have there, just a matter of multiplying what we have here by 100. So I change what I want the function to compute on the vector of weights, and so I do this, and then I say multiply it by 100. So we have this particular result that we are seeing on the console. So again, one way to which we can do this is to as well say mean, and then that $feed the mean for the guy, the chick fed with casein. So if you run this, it also gives us the same proportion that we have been looking at. Another way to do this is to say we use the table function, and so we say table that $feed, and if I run this entire thing, we have this unique number of replicates for each of the unique levels of the feeds. So if I divide this by the number of rows, look at what will happen, the number of rows of that, and so if I run this, you see we have again what we achieved using the typely function. And so it is also possible in the case where you want to convert this to like percentage, to say by 100, and so you have exactly what we also achieved with this line of code that we have from line 10 to 11. So again, you can do this with the tidy. So let us say we want to introduce this concept of tidy, so I'm going to say that and then $. So I'm going to first group by the feed. So I say group by, and then I put the feed. So the result of what we have at the level of the pipe to this function will be what will be available for whatever kind of function we want to do in the next pipe. So I'm going to say summarize, and so I break down this code to this point, and so I'm going to count the number of unique observations. We have done this before in the last video when I talked about how to use the count function in R. So I'm going to call this observe, the count of the observations, and then I just use this n to count, to have the unique count of the observations. So if I run it to this point, you could see this is the result we have. So don't be confused, this is just still similar to what we did before, but what I want to do in this case is to go a step further and do something to have, like, let's say the proportion and again the percentage. So I'm going to add again another pipe that is going to be working on this result we have on the console that has just two columns, the feed and the observation count. So I'm going to say this, and I'm going to use the mutate function from the dplyr because I want to create a new variable that is going to be derived from the existing variable observation count. So I'm going to call this observation proportion obs prop, and then I'm going to say it is equal to observation count divided by the sum of observation count. Yes, so I will stop at this point and then I run again, and so you could see again added to the table we have again the proportion of this the count of the observation. So again I want to have a new variable again added to the existing table we have. So I'm going to call this observation percentage, and then this is going to be exactly what we have in this place, but we have it multiplied by 100. So I copy everything we have in this place and then I paste it here, leave this again into a big bracket, and then I say this multiplied by 100. So if I run this entire line of code from 18 down to 21, then I have a new one created. So it is also possible for us to understand like the proportion of chick that we fed with not just one feed. It is possible for you to understand the proportion for chick fed with more than one levels of the feed. Remember, when we want to understand the proportion for those fed with one level, we said sum, and then we said that $ feed that is equal to casing, and then we have this unique value, and what we did again was to say number of rows, and then we say that. So this gives us the proportion. So what I'm saying here now is that it is also possible for us to have the proportion for more than two levels. So how do we do this? So we go by saying again sum for that $ feed. Let's say we want to see that of casing and one other feed again. So I say equals to, then I say this casing, and then I use this or condition, and then I go again or the one with the feed that is equal to, let's say, sunflower. So if I take the sum, it's just gonna be, let me write a new line of code in this place, sum that $ feed that is equal to sunflower. So let me run this line of code. This is 12, sunflower is 12, and again let's run that of casing. So that's why we have the combination for what we have at line 27 to be 24. So in terms of proportion, it's also going to be the summation of the two. So then I add the number of row, and then I say DAT. If I run this, this is 0.1690 as the proportion, and this is also 0.1690. So the summation is the proportion for the combined level of feed fed with this particular chick fed with casein and sunflower will now be this divided by number of rows of DAT. So if you run this, it's similar to what we have as the summation of this, or the multiplication of these by 2. So this is the way to which you can perform proportion and percentages in R. So thank you very much for taking our time to learn R with me. I wish you a blessed day. Ciao.